Guys, this is video 5.4 part 1. I'm going to split this topic up into two videos. The first video is going to be the more basic structures, and then part 2 is going to be dealing with more of the advanced special case scenarios. Okay, we're going to be drawing covalent bonds. This is a little bit more in depth than the ionic bonding that we did in 5.3. This takes practice, okay? It's a process. Don't skip steps. Make sure you understand the process, and you can do it without looking at your notes before you take your quiz, all right? So let's jump in. Our first structure we're going to draw is iodomethane. Now, you don't have to worry about naming. Naming comes in our next unit, Unit 6. That's when we'll get into naming compounds. So right now I will give names, but I'll also give you the formulas, and the formulas are what you need to be concerned with. Now, you can see 5 steps listed here. Again, these are for the basic scenarios, and then we will add on a few more steps in the next part. But before we jump in and talk about the the steps, let's just talk really quickly, guys. So this is what a structure will end up looking like, okay? And we will draw or use the atomic symbols to represent the atoms of each element. We will connect those through bonds. Okay, so when you see one dash or line, it's called a single bond. Now, you can have more than a single bond, but in this first part, we're only going to be dealing with single bonded structures. We'll get into double and even triple bonds in our next video, so just kind of hang tight with that. But you got to understand first is that the number of electrons being shared within a single bond is 2. So on every one of these lines at the end is like it's a dot. Now, one dot comes from hydrogen and one is coming from carbon. Think about covalent bonds. What's happening with their electrons? Their electrons are being shared. So that's why one is from one element and one is from the other. So every single one of these lines is like having 2 dots because there's 2 electrons within the line. Now, the number of electron pairs shared between the carbons or between the different elements would be 1. So notice how questions are very, very similar. These two questions are very similar, but one is talking about the number of electrons and one is talking about electron pairs. And that will be something that may trip some of you up. So make sure, again, that you are reading and answering the question that's asked. That's the biggest thing when it comes to Regents questions. All right, so we're going to go ahead and draw the structure of iodomethane. We're going to use the top part here. So step 1 and 2 we're going to kind of do together. Determine the number and type of atoms and then determine the number of valence electrons. So there's a little formula that I like to use, okay? So I'm going to count my number of atoms. So I've got 1 carbon, and then I've got how many valence electrons does carbon bring to the table. This is where having your reference tables out, your periodic table, is going to help. When you look at carbon, it's in group 14, so that means it has 4 valence electrons. So what this first one means is that this is the number of atoms, and the second one is the number of valence electrons, okay? And this is going to be our data for carbon. Now, we're also going to have to include all the elements within a formula, so go on to the next one. How many atoms do we have of hydrogen? We've got 3, okay? And then we have 1 valence electron for each hydrogen. And then we have iodine. I've got 1 iodine atom, which has 7 valence electrons. So notice we can just continue this process to add up the number of valence electrons depending on however many atoms we have. Okay. Now, you don't have to necessarily worry about drawing these arrows with the elements right or beyond this example, guys. I want to just show you that this is where I'm getting the numbers from. So the first one is the number of atoms. The second parentheses then is the number of valence electrons, and I'm trying to figure out to get the total valence electrons because that's what's taking place. That's what we're going to use in bonding, okay, are those outermost electrons. They're the ones that are typically unstable because they're not in a full octet or full energy level. So 4 plus 3 is 7 plus another 7. We have 14 valence electrons that we have to use. However many electrons, guys, that you calculate, you have to use all of them in your structure. So step 3. So that's step 1 and 2, okay, all in one step. Step 3 is we're going to arrange the atoms to form a skeleton structure. Okay, so the central atom is typically the first one that's written in your formula unless it's hydrogen. Now let's think about why can't hydrogen be the central atom? How many electrons can hydrogen hold? Guys, hydrogen can only hold 2 electrons because it's in the first energy level. Okay, so therefore it can never be the central atom. We're going to jot a note up here to the side. H can never have more than one bond. It cannot have a lone pair, it can't have a double bond or a triple bond, it can only ever have one bond. And that's something that many will forget because they'll get lost in the process, and this is where practice comes in handy. Okay? So carbon, if you see carbon, carbon's going to be your central atom. It's a great sharer. It's in group 14. It can either gain or lose 4, so it loves to share. So I start with my carbon, my central atom. Then I'm going to just put all the other elements around it. So it doesn't really matter where you start. I typically start at the top, and then I go clockwise. So I'm just going to arrange those, and I'm going to connect them using single bonds first. Okay? Always, always, always start with single bonds. Now, how many electrons have I added in there? Well, I've got 1, 2, 3, 4, 5, 6, 7, 8. So I need to subtract out from my 14 total. I need to keep track of how many electrons I've used. So I've got 8 what we call bonding electrons. Okay, that means they're used in bonds. So that means I have 6 left over. These 6 that remain are going to be lone pairs. Okay, lone pairs electrons. So we're going to use them on putting lone pairs, which happens to be step 4. Now again, think to yourself, how many electrons does every element need? Every element wants to get to 8 except for hydrogen. Hydrogen wants to get to 2, right? So remember, except hydrogen can only hold 2 electrons. We already wrote that down. So if I look, each hydrogen has 2, so 1, 2, 1, 2, 1, 2. All right, hydrogens are good. Carbon wants 8. It has 8 as well. 1, 2, 3, 4, 5, 6, 7, 8. Iodine is the one that only has 2. How many more does iodine need to get to 8? Well, 2 plus 6. Oh, look, I happen to have 6. So I'm going to subtract those out. Those are going to be used as lone pairs around oxygen, which then means all of my electrons have been used up. I have 0 left, and every single element here in my structure now it has a stable octet, or in hydrogen's case, a duet because it has just 2. Okay? So notice, it's a big process. You can't skip steps within the process. So let's do a couple other practice problems together. I'm going to just draw a line to kind of separate. So NH3, what's my first step, guys? Steps 1 and 2 we're going to do together. So figure out how many valence electrons you have to work with. So count up your atoms. I've got 1 nitrogen. How many valence electrons does nitrogen have? It's got 5. I've got 3 hydrogen atoms. Each hydrogen has 1 valence electron. So 5 plus 3 gives me a total of 8 valence electrons. Okay, so step 1 and 2, I've got 8 valence electrons. Now I want to do my skeleton structure. So figure out what's your central atom. It's going to be the first atom unless hydrogen is there first, and then you skip over it and go to the next one. So nitrogen is first. That's good. We can use it as a central one. So I'm going to jot down nitrogen. I have 3 hydrogens. I'm just going to put them all around nitrogen. Doesn't really matter what order or where I put them. I'm going to connect those to nitrogen using single bonds. Okay. So how many electrons did I use? Well, I used 6. I have 2 more that I need to use as lone pairs. So again, can I put lone pairs on hydrogen like this? Absolutely not. Hydrogen cannot have more than a single bond. Therefore, my lone pairs have to go on nitrogen. So I used my last 2. I have none left over. How many do I have? Hydrogen has 1, 2. Remember, there's 1 here, 2 there. So hydrogen has 2. This hydrogen has 2 as well. And same as this. Nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. Look at that. There's my structure for ammonia. All right, let's do one more together, and then you guys can practice the last 2 on your own. Silicon tetrafluoride. So again, count up how many valence electrons you have. I've got 1 silicon atom. How many valence electrons does silicon have? Should be 4. It's in group 14. It's right below carbon. All right, plus I've got 4 fluorines. each fluorine has 7 valence electrons. So 4 times 7 is 28, plus 4, I've got 32 electrons that I've got to keep track of. So it's very important, guys, that you are good at bookkeeping to make sure that you use up all of the electrons and that you don't put extras in there as well. So ask yourself, what's going to be my central atom? Well, it's the first one. It's not hydrogen, so I can use it. Silicon is a great sharer, just like carbon. Group 14 ones are great sharers. Then I'm going to arrange my 4 fluorines all around. So what am I going to do next? Well, you need a skeleton structure, so I'm going to connect them with single bonds. Always, always, always start with single bonds. So how many electrons did I use there? Well, 2, 4, 6, 8. So I've got 32 minus 8. I've got 24 more electrons excuse me, that I have to use. Now, let's think. Silicon has 1, 2, 3, 4, 5, 6, 7, 8. Silicon's happy, but each fluorine only has 2. So I need 6 more for each. So start adding them in as lone pairs. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 times 4 equals 24. Oh, look, I used all my electrons. So each fluorine has 1, 2, 3, 4, 5, 6, 7, 8. Each of them has 8, and silicon does as well. So that would be our final structure for silicon tetrafluoride. Guys, the more practice you do, the easier and quicker this gets. So why don't you guys go ahead and try Bri and CH3Br. All right, so I'm going to do Bri right here. I'm going to do CH3Br. So if you get confused with something I do, because I'm going to go a little bit quicker, pause the video and ask for help. All right, it's what I'm here for. So I've got bromine and iodine. So I've got 1 bromine, 7 valence electrons, plus 1 iodine, also has 7 valence electrons. So I've got 14 that I need to use here. Now, Bri, there's no real central atom because there's only 2. So when you have only 2 elements in a compound, there's no central one. They're just kind of next to each other. Okay, connect them with a line, single bond, so subtract out 2. I've got 12 electrons left. Just so happens that each of these guys needs 6 more, so it works out perfectly. Boom. There's what our structure for Bri would look like. All right, moving on to the last one here. I've got 1 carbon, which has 4 valence electrons. I've got 3 hydrogens, which has 1 valence electron. I've got 1 bromine, which has 7. So 4 plus 3 is 7, plus 7 is 14. As you went through this, guys, I hope that this structure looked somewhat similar because it's actually the same as the iodomethane one that we did originally, except instead of iodine, we have bromine. So process will be the same. I'm going to start with single bonds. There's 8 electrons. I've got 6 more. Where can I put lone pairs? Does hydrogen need any lone pairs? Absolutely not. Hydrogen only gets a single bond, so that means the last 6 are going to go on bromine. Just like that. And there's what my structure would look like for bromomethane. All right, guys, so that's part 1. All right, ask questions if you need help. Part 2, we will get into some more challenging structures.